Hi guys, welcome back to CompEdge. Today we are going to learn everything about relative speed concept. Please subscribe to the channel for more awesome content like this and also click on the tiny bell icon for notifications whenever a new video is released. From the previous class, we learned the relationship between time, speed and distance and also the average speed concept and have solved multiple problems based on the concepts. Now you can refer to the videos, the previous videos for a clarity on those concepts. Now this is the third video in the series and this video deals with relative speed concept. Now, relative speed. Relative speed, as the name itself says, is speed of one body with respect to another. Now there are two cases in the case of relative speed, that is if two bodies are moving in the opposite direction with speeds s1 and s2 and two bodies moving in the same direction with the speeds s1 and s2. Suppose two bodies are moving in opposite direction with s1 and s2 speeds, the relative speed of one object with respect to other will be written as s1 plus s2. So the speeds get added up when the objects are moving in the opposite direction. And also in the second case, when the objects are moving in the same direction, the speeds get subtracted. So there are two cases that arise in this. If speed of one object is greater than the other, we write s2 minus s1 in the case s2 is greater than s1 and s1 minus s2 when s1 is greater than s2. So in this case, whichever speed is greater, we write that first and we subtract it with the other speed. So this is the entire concept that we use in relative speed, and let's delve into the problems based on this concept. Now the first question that we're dealing here with, let us read the question. A starts walking from a place with a uniform speed of 2 km per hour. So A starts walking with a speed of 2 km per hour in a certain direction. So suppose he's walking to the right. After half an hour, B starts from the same place and walks in the same direction as that of A at a uniform speed. Okay, so we do not know the speed of B, so let the speed of B be SB. And he overtakes A in 1 hour 48 minutes. Calculate the speed of B. So that's our question here. So how to use relative speed concept here? Now, what is the relative speed of B with respect to A? So the relative speed of B, right, relative speed is nothing but SB minus SA, that is nothing but SB minus 2. Now we all know that from the relationship between time, speed and distance, we know that distance is equal to speed into time. In the same way, relative speed into time will give you the relative distance. So relative distance is the distance with respect to the other object. Now the relative distance in this case, now at time is equal to half an hour, SB is starting out, right? So he has to cover an extra distance of 1 kilometer, which is covered by A in half an hour. Since his speed is 2 kilometers, in half an hour he would cover a distance of speed into time, that is 2 into half, that is 1 kilometer. So he would cover 1 kilometer in half an hour. So B should be covering up 1 kilometer, and after that he moves along with A and crosses A at a point of time. So what is the extra distance that B has to cover in the given time? It is nothing but 1 kilometer. So relative speed, that is SB minus 2 into the time. Time is 1 hour 48 minutes. So let me convert it into hours completely. So this is 1 plus 48 by 60. This 8s are, 10s are. So this becomes 1.8 hours. So SB minus 2 into 1.8 is equal to the relative distance, that is 1 kilometer. So from here I would get SB minus 2 is equal to 1 by 1.8. From here I would get this as SB is equal to 10 by 18 plus 2. If I simplify this, I'll get this as 5 by 9 plus 2. This is 23 by 9 kilometer per hour. So this would be the speed of B. So what have we done here? We have taken the relative speed and we have taken the relative distance that B covers with respect to A and the time taken to cover that distance. Okay, so SB minus 2 into 1.8 will give you 1. So the answer here, the speed of B is nothing but 23/9 km per hour. Now coming to the next problem. In the next problem, let us read the question first. Two bodies A and B start from opposite ends P and Q of a straight road. They meet at 0.6 d from P. Find their point of the fourth meeting. Now these kind of problems often arise in our competitive exams. Now let us pay a close look here. So A is represented in this green color. So A starts from P and B starts from Q, right, in two different directions. Now A and B meet at the first meeting point, that is M1. Alright, so when they first meet, so at their first meet, what is the total distance covered by them? The total distance covered by both A and B is nothing but D, right? So D is the total distance between P and Q. So the total distance covered by both the objects is D. Now what would be the, suppose I take the speed of A as SA and speed of B as SP. A covers 0.6 d in a particular time t and B covers 0.4 d in a particular time t, so that they both meet at this point. So if I consider that again, if distance is equal to speed into time, so d1 by d2 is equal to s1 by s2, because here the times are same. So from here we will get 0.6 d divided by 0.4 d is equal to SA divided by SB. From here we will get the ratio of the speeds as SA by SB is equal to 3 by 2. So this is a very important relation. Now at the first meet they will cover a distance of t. Now this is at the first meet. After the first meet, A would further go on and then it would come back to this point, and B would further move on to the left and it would come back again, both of them to meet at this point M2. Now when they meet at M2, what is the distance that they covered? Now A, if you just see this, okay, A would cover this green line distance, okay, from here to here, right, and B would cover this blue line distance from here to here as well as from here to here. Now if you consider this, right, in the first line this total distance is d, and the second line this total distance is d. So when they had to meet for the second meeting, the total distance covered by both the objects is nothing but 2d. So for second meeting, both the objects cover a total distance of 2d. So for the first meeting they cover a distance of d, for the second meeting they cover a distance of d, and also for a third meeting they will again cover a distance of 2d, and for the fourth meeting as well they will cover a distance of 2d. So the total distance covered by both the objects is nothing but d plus 2d plus 2d plus 2d. So this will be nothing but 7d. So the total distance covered by both the objects is nothing but 7d. If the total distance is 7d, the distance covered by individual, suppose dA is the distance covered by A and dB is the distance covered by B. Since the times are same, again this relationship is valid. So we can write dA by dB is nothing but again equal to 3 by 2. So what is the distance covered by A? Distance covered by A will be nothing but 3 by 5 of 7d. So this is distance covered by A. From here we would get dA is equal to 4.2d. Now where is 4.2d? That is nothing but you cover a distance of from P to Q, you cover a distance of d, again go back again d, again go back again d, again go back. So 4 times you go to and fro, and after that you cover a distance of 0.2 from A, right? So where is the fourth meeting? The fourth meeting would be at 0.2d from A. Fourth meeting would be at 0.2d, 0.2d from the point P, right? So this would be where the objects would meet for the fourth time. So this becomes very important, where you have to deduce this fact, that is at the second meeting, from the second meeting up to the nth meeting, they will cover a distance of 2d at before every meeting. So initially they will cover a distance of d, and after that they will start covering a distance of 2d before every meeting. So this is the crucial step of the problem. and after that the total distance will be in the ratio of their speeds, and hence we can find out the location of the fourth meter. I hope you've understood this problem. It was as simple as that. Now coming to the third problem. In the third problem, let us read the question again. A man walking at a constant rate of 4 km per hour is passed by a woman traveling in the same direction. So both are traveling in the same direction along the same path at a constant rate of 20 km per hour. So the man is moving at 4 km per hour. The woman is moving at 20 km per hour. The woman stops to wait for the man 5 minutes after passing him. So basically the woman and the man keeps walking in the same direction, and after 5 minutes the woman, obviously she has the greater speed, so she'll move further than the man and she'll stop there for after 5 minutes while the man continues to walk at a constant rate. Now how many minutes must the woman wait until the man catches up? So this would be the question. Now let us see how to apply the relative speed concept to it. Now we know that since both the man and women are walking in the same direction, the relative speed would be the difference of the speeds, that is relative speed is nothing but 20 km per hour minus 4 km per hour, that is 16 km per hour. Now what would be the relative distance that a woman walked compared to the man in the time of 10 minutes? So the relative distance will be nothing but the relative speed into time. Okay, so this will be 16 into 5 minutes. So let us convert 5 minutes into hours. So 5 by 60. So this will be 1 by 12th of an hour. So I can write this as 1 by 12. So from here we will get 4 by 3 kilometers. So the man has to cover 4 by 3 kilometers. So from here till here, so it is 4 by 3 kilometers. So now man has to alone travel this 4 by 3 kilometers in order to catch up with the woman. So again, using the basic relation that we have for distance, speed and time, distance is equal to speed into time. Distance is nothing but 4 by 3. Speed of the man is nothing but 4 km per hour. We have to find the time. So from here we'll get 4 into t is equal to 4 by 3. So t is equal to 4 by 3 into 1 by 4. So you'll get this as 1 by 3rd of an hour. So if you convert this into minutes, since the question is asked in minutes, we'll get this as 20 minutes. So the woman has to wait for 20 minutes in order for the man to catch up. So this becomes the answer for this question. So this is how relative speed concept is used in solving problems like this. Now, this is the challenge question of this video. Try to answer this challenge question in the comment section. You can use all the concepts that are used up to this video, that are discussed up to this video. So in this video, we dealt all about the relative speed concept. In our next video, we will be discussing all about the trains and the concepts related to it. If you like the video, please give a big thumbs up, share it with your friends, and also comment the answer for the challenge question in the comment section. If you have any doubts in the topics discussed, please post them also in the comment section. We'll make a separate video on them. Thank you so much for watching, guys. Until next time, bye-bye.